All right, page 39 when we're done. Operations with functions. This is a review from Algebra 2, all right? We are not doing compositions yet. We'll do that after the test. This is just combining them with adding, subtracting, multiplying, and dividing, okay? So functions can be combined using addition, subtraction, multiplication, division to create a new function. So this is f plus g of x. Another way to write that would be f of x plus g of x, right? Means the same thing. And then f of x minus g of x is the same as f minus g of x. When you multiply them, this is like a little dot in between them here. This would be like f of x times g of x. And then we have f over g of x. So that would be like f of x over g of x. Everybody okay with all of that? Yes? No? Maybe? Okay, thank you. All right, so let's look at which ones we are going to do here. We are going to start with, I have them marked, and I don't remember if I marked them because I was going to do those or marked them because I wasn't going to do those. We'll start with example 1. We'll go ahead and do example 1. It says, oh, I'm about to skip that though. The domain. We have to look at the domain before we start, okay? Before we actually do any of these. The domain of the new function is the intersection of the combined functions. That means what they have in common. The domain is further restricted with the quotient function to exclude values in which g of x equals 0. So let's think about what that means. So first of all, this is the sum. This is the difference. What would this be called? What's it called when you multiply? If you got some difference, what's your answer to a multiplication? It's called the, starts with a P, product. And then when you divide, it's the quotient. Okay, I just want to make sure we know. So sum, difference, product, quotient, right? So the quotient is restricted because g of x can't equal 0 because you're not allowed to divide by 0, right? Does that make sense? Understand that? Okay. So let's look at these. We've got f of x and g of x, okay? And so what is the domain of this function right here? What do you think that is? All real numbers. And we are going to use set notation and some inequality notation here and not interval. I still want you using interval with the graphing and stuff, but I worked all this stuff out with interval, and with some of this, it gets a little nutty with interval notation. So it's all real numbers. We're going to actually call it all real numbers. Because when I graph this, what is this thing when I graph it? What's the parent function? Quadratic. And what's the parent function here? Linear. So what's the domain? All real numbers, right? So the intersection of those two domains is all real numbers. So whatever the intersection is, that's the domain for A, B, and C. We're going to have to look at it a little bit further in D. So let's start with A. I want f plus g of x. So that means I just take f of x, which is x squared plus x, and add it to g of x, which is 3x minus 1. And then I just simplify. So f plus g of x is equal to x squared, then what? Plus 4x minus 1. And then I have to look at the domain, right? So the domain here is the intersection of the two. So since they were both all real numbers, this is all real numbers. Everybody okay with all of that? You good? So then f minus g of x. So f of x is x plus x, I'm sorry, as x squared plus x minus 3x minus 1. Did I substitute that correctly? Did I substitute it incorrectly? No, why not? Parentheses, good. Technically, whenever you substitute things in that have more than one term, like I should have had parentheses here and here, but it was okay that I didn't because it didn't affect anything, right? Even these here, if I leave those off, that's fine, but these, make a difference, right? That's important there. So this becomes then f minus g of x is going to be equal to x squared, and then I've got x minus 3x gives me what? Negative 2x. Because I have 1x, I subtract 3 from it, I get negative 2x, and then what comes next? Plus 1. And my domain here, because it's the same as A, right? A, B, and C will all have the same domain. It is just all real numbers. Okay, f times g of x is going to be f of x, which is x squared plus x, times g of x, which is 3x minus 1. Did I substitute that correctly? I mean, I have to put parentheses, right? Having this, I'm actually just multiplying by the x here, right? I've got to have that. Then I have to multiply, right? So when you multiply something like this, what kind of process do I need to use? FOIL. Okay, and if you don't FOIL, if you distribute or if you do the box or whatever, that's fine. I'm going to call it FOIL so we know, I mean, that's how I'll do it. But we multiply the first two together, so x squared times 3x is what? 3x cubed, good. Then the outside 2, so x squared and negative 1 is negative x squared, right? And then x times 3x is a positive what? 3x squared. And then x times a negative 1 minus x. Everybody good? So that means that f times g of x is equal to 3x cubed plus 2x squared minus x. And my domain is all real numbers. Everybody okay with all that? When we get to the quotient, it said up there, the domain is further restricted because g of x, or whatever's in the denominator, which happens to be g of x, cannot equal 0. So I need to write down that g of x cannot equal 0 because we are not allowed to divide by 0, right? So what g of x is 3x minus 1. So 3x minus 1 cannot equal 0. You can solve for x right here, just like you solve for x if it did say equals, right? So I can add 1 to both sides, so that means that 3x cannot equal 1. So x cannot equal what? 1/3. Good. Do you see how it's the exact same solving? But it's better for you to put that it can't equal it instead of trying to solve for it and let it equal, and then you're not even sure why you have it. Okay, so this is a further restriction on my domain. I actually didn't have any restrictions. It was all real numbers. I got restrictions now, right? And so when I come over here, f over g of x, I'm going to substitute all that in, right? So my f of x is x squared plus x over g of x, which is 3x minus 1. Can I reduce this at all? No. If I could possibly, then maybe in the numerator I could factor out that x, but if I factor out that x, I'm just left with x plus 1, right? And that thing's going to simplify. I cannot simplify this at all, so this does equal f over g of x. My domain, however, is not all real numbers. It's all real numbers except x can't equal 1/3. So I can write that a couple of different ways. I could write it in inequality notation. I can write it in interval notation. That's how we've been doing it. But we can also write it in set notation. I can say that it's a set of all x's such that x cannot equal 1/3. You need to know what that looks like too. Okay. Everybody okay with all of that? Any questions at all? Okay, so we're actually going to skip example 2, and we're going to go to example 3. All right, so my domains. What's the domain of this function right here? What is this function? What's this parent function? Cubic. Okay, let's look at this visually. This is a cubic, right? So That's what it looks like, right? Your domain is all real numbers, right? This is why you want to be able to think of your parent function. Because even though this isn't the parent function, if the parent function has a domain of all real numbers and all I do is transform it around, stretch it, and move it and whatever, is it still all real numbers? Yes. So what's this parent function for g of x? Quadratic. It looks like this, right? So what's the domain? All real numbers. Okay? We good with that? That's how you can make sure that you know. All right, so now we move on. And that means that here for a, g plus f of x, we get x squared minus 4x plus f of x, which is 2x cubed. Now, can I actually combine any of that stuff? No, which means I just kind of rearrange it and get g plus f of x is equal to 2x cubed plus x squared minus 4x, because I should have it in decreasing exponents, right? So what's my domain here then? All real numbers, because it's the combination of those two. Good. All right. So then, f minus g of x. F, which is 2x cubed, minus g of x, which is x squared minus 4x. And those parentheses matter, okay? Some of the most common mistakes happen with signs when it's stuff like this, when we know better, but sometimes we just mess things up. But that means that f minus g of x is equal to 2x cubed minus x squared, then what? Plus 4x. And what's your domain? All real numbers. Very good. Everybody okay with all that? So then f times g of x. So f, which is 2x cubed, times g of x, which is x squared minus 4x. This is pretty simple to do. This would give me f times g of x. So what's 2x cubed times x squared? Yeah, because when you multiply them, what do you do with the exponents? You add them. Good. So it is 2x to the 5th minus what? Okay. 8x to the 4th. Huh? No? You have a question? You got it now? Okay. All right, good. Any questions at this point? So what's my domain here? All real numbers. Good job. Alrighty. So then we're going to look at this. We're at the quotient. The denominator, which is g of x, cannot equal 0. So g of x cannot equal 0. G of x is x squared minus 4x, and it cannot equal 0. Okay, everybody okay with that? Do we understand why it can't equal 0? Because it's going to end up in the denominator, and you're not allowed to divide by 0, right? Okay, so now I've got to figure out what the actual x values that can equal 0 are. How do I solve a situation like this? Okay, what do you mean by simplify? We would factor it out. Is that what you meant by simplified? Okay, it's kind of what I figured. But so I'm going to factor this out. Like if here's what you don't do. I'm not going to add 4x to both sides and divide by x. That's a bad idea, right? But I'm going to I can factor out this x, right? So this is a quadratic, so we try and factor. So x times x minus 4 cannot equal 0, right? So then we solve this just like if it was a, it was a normal quadratic without the can't equal 0, right? So x cannot equal 0, and x minus 4 cannot equal 0, right? So here's one of the values we have to use, and this x cannot equal what? 4. So it doesn't get to equal 4 or 0, neither one of them. So now I know what to do with my domain. I go over here. I substitute this in f, which is 2x cubed, over g, which is x squared minus 4x. Now I can simplify this. What do I need to do to the denominator to be able to simplify? Say that one more time. Okay, but divide by x, you mean I need to do, what's I need to factor it out, right? X times x minus 4, and then 2x cubed up here. Now can I cancel a 0 out of the numerator with that? I'm sorry, not a 0. An x out of the numerator with this one right here? Yes? Okay, so this means that f over g of x is going to equal 2x squared over x minus 4. You don't have to. You can. It doesn't hurt anything, but you don't have to. Okay, everybody with me so far? Okay. So my domain, right? It's not all real numbers. It got restricted by this, right? It's all of the x values such that x cannot equal 0 or 4. If you wait until the very end to look at your domain, look what happens here. If I just looked at this, then I would just think that x can't equal 4, right? But that's not true. X can't equal 4 and it can't equal 0. I don't get to see all of that at the end sometimes. Sometimes I do, sometimes I don't, but that's why we have to look at it first, okay? And that's what's going to get us some holes with our rationals. You wonder how like that removable discontinuity happens? It happens with stuff like this, okay? Everybody good so far? Well, it's whatever. It's not always all real numbers necessarily. It's whatever the combination of these two are, and we'll look at one in just a minute that's not going to be all real numbers. And then once I decide what this one is, the first three are going to be the same. It's the fourth one. It's the quotient one that gets further restricted, okay? Put your phone in there before I take it. Excuse me. All right, so let's look at, all right, let's look at this one. 1 over x. So what is our domain here? 0 to infinity. Can it be 0? No. Can I plug in everything but 0? Yes. So really it's just that it's all the x's such that x can't equal 0, right? So if I was going to write it out the way we've been writing the reciprocal, it goes from negative infinity to 0 and then 0 to infinity because there's an asymptote there, right? So here, I don't get to divide by 0, so that means x plus 2 can't equal 0, so it's all the x values such that x can't equal what? Negative 2, right? And you remember that from rationals last year, right? That's how you knew where your asymptotes were with your rationals, and we're going to look at those again, but we know it can't be negative 2 because we can't divide by 0. All right, so when we look at these domains together, right, it's what they have in common, which means I have to put them together. So all real numbers except that x can't equal 0 or negative 2. That's what's going to happen in A, B, and C when we get there. Okay. So let's look at A. F plus g of x. So f of x is 1 over x plus g of x, which is 2 over x plus 2. Okay. I've got to add these together. What do I need? Common denominators, okay? Do you remember doing rationals last year? You remember getting common denominators with stuff like this? Or that calculator now does not help you with fractions, right? Your common denominator is a combination of these two. So basically, as a little reminder, because I'm not sure if we need these reminders or not, but I need to multiply this first fraction by, let me do it this way. We're going to write out a step that you may not actually need to write out every time. I just want to make sure you all understand where it's coming from. I'm going to put 1 over x times x plus 2 over x plus 2. And that's plus 2 over x plus 2. And this one has to get multiplied by x over x. Okay? Does that make sense to you? Remember doing that? All right, so now I just multiply straight across. So for this first one, I get x plus 2 over x times x plus 2 plus 2x over x times x plus 2. Now we have the same denominators. Does that make sense to you? You with me on that? Or did I lose you? Ask me a question. It's like if I'm going to, here, let me see where I can. If I'm going to add 1/2 plus 1/3, right? If I'm going to add those together, then I have to multiply this one by 3/3 and this one by 2/2. Do you agree with that? That's how I get 3/6 plus 2/6, so I can add them together, right? That's how we get our common denominators. That's what we're doing on the other ones. We just have variables in there, okay? You just take whatever that denominator is. The looks on your faces are worrying me just a little bit because I understand you may not feel like a rock star at it, and I could give you a test on it right this second, but it should look familiar. So does it look familiar? Yes, okay, that's what I want to know. Okay, if we're rusty, that's one thing, but it looks familiar, it's not totally foreign, right? Just stay with me and it'll get better as we go. Okay, so then when I add these together, the denominator just stays x times x plus 2. The numerator becomes 3x plus 2. Can I simplify that at all? No. Because I have nothing, I'd have to be able to cancel out an x from the numerator. Do I just get to cancel this x with that x? No. Do I just get to cancel this x plus 2 with x plus 2? No, it doesn't work that way. So I can't simplify it at all. So the good news is I really can't do anything else, and it's fine. So this is f plus g of x. My domain then is all the x's such that x cannot equal -2 or 0. Okay, everybody with me so far? Maybe? Okay, so let's try this next one. Now we're going to subtract. So g of x is 2 over x plus 2 minus f of x, which is 1 over x. I don't get just to subtract the numerator, subtract the denominator. We at least know that that doesn't work, right? So now I'm going to have to get the common denominators again, just like I did over there. This one has to get multiplied by x over x. This one has to get multiplied by x plus 2 over x plus 2. So this becomes 2x over x times x plus 2 minus, and then this gets multiplied by x plus 2 over x times x plus 2. Everybody with me so far? Does my denominator change when I combine these? No, it doesn't. So my denominator stays x times x plus 2. Yes? So what do you think my numerator is? X plus 2? Or x minus 2? Okay, so look at what's happening here. You're subtracting all of this, right? So 2x minus x is x. Minus 2 minus 2. Because I could combine this all into one fraction, right? We don't have parentheses there. You don't have to put them there, but you have to understand that you're subtracting both things. Does that make sense? Because you're subtracting that binomial there. Everybody okay with all that? Can I simplify this? No. If this was x plus 2, could I have? Yes, then I could have canceled out, but that's not what it is. So this is equal to g minus f of x. So the domain is the same as the first one, all the x's such that x does not equal -2 or 0. Okay, so this is good. I'm pushing you out of your comfort zone a little bit because y'all look a little freaked out. Don't worry, there's not a ton of these coming right now, but it's coming, and it's a review, okay? So you got to make sure that that doesn't get you too freaked out there. All right, g times f of x. So g is 2 over x plus 2 times f of x, which is 1 over x. Do I have to get a common denominator? No, I do not. You do not have to get a common denominator when you're multiplying. That's nice. Multiplying fractions is super easy. We just multiply straight across. And we get 2 in the numerator, and we get x times x plus 2 in the denominator. And that's equal to g times f of x. Multiplying and dividing fractions, way better than adding and subtracting fractions. And your domain here is still the same. It's all of the x values such that x does not equal -2 or 0. Now we're at the quotient. The denominator, which is going to be g of x, cannot equal 0. So g of x, g of x cannot equal 0. Now, let's think about this before I blow your mind, because I'm afraid if I do, what's going to happen right here, it's just going to throw you off on some confusion. Is it possible for me to substitute in any value of x where this is going to have a value of 0? Think about that. It's not, right? Because there's no variable in the numerator, there's no way that that thing is going to equal 0. Does that make sense to you? So let me show you what happens if you just go about this the same way you've been going about the rest. So 2 over x plus 2 cannot equal 0. So if I want to solve this, if I multiply both sides by x plus 2, that means x plus 2 times 0 is just 0. So I get 2 cannot equal 0. When y'all get stuff like that, you're like, oh, Lord, I messed up somewhere, right? Like something ain't right. Well, okay, so 2 can't equal 0. Do you agree with that? Is that a true statement? Yes, it is. Now, if you got 2 equals 0, that's a problem. But you got 2 can't equal 0. You're like, I agree, 2 can't equal 0. I don't have any more x's that's going to further restrict my domain because it's impossible for this thing to equal 0. That's why you get something weird, okay? But if you can reason through and know it's not going to equal 0 anyway, you don't even have to do that. So don't let this freak you out. And that's why I wanted to talk about it first. So there's not any further restrictions on my domain. It just cannot equal 2, and it cannot equal 0. So then I go and I substitute it in. F of x is 1 over x over g of x, which is 2 over x plus 2. Now, I know you don't like the way that looks, right? I know we don't love fractions to begin with. We get this, and we're like, oh, Lord, that's crazy, right? Is that really as bad as it looks? What's your rule for when you divide by fractions? You multiply by the reciprocal. So this is actually 1 over x times x plus 2 over 2. It's just the reciprocal of that denominator. Then multiplying fractions, super easy. What do? You just multiply straight across, right? So that means that I get f over g of x is equal to x plus 2 over 2x. And can I reduce that at all? Nope. So my domain is x such that x cannot equal negative 2 or 0. Oops. Wrong place. Come on, catch up. There we go. Everybody okay with all that? There's not going to be a bazillion of these kind with this right now, but you do need to make sure you can think your way through that. Everybody okay with all that? All right. Let's look at example 5. We got to talk about domains here, right? Let's look at the parent function. What's this parent function called? Square root. So this is what a square root parent function looks like, right? Do we all agree with that? Okay. So what does this do to my parent function? Translates it to the left 6, right? So it would look something like this, and this would be here at negative 6. So my domain are my x values, right? So that means all of these x values have to be what? Greater than or equal to negative 6. Does that make sense to you? I don't even have to do any algebra. Plus, I should know that everything underneath of there has to be 0 or greater. So x plus 6 has to be greater than or equal to 0, and that's where you get that from. This, what kind of transformation happens here? Right, 2. So it looks like this. So that's at 2. So guess what? All of your x values have to be greater than or equal to what? 2. You see how that works? Okay. I mean, you could do it algebraically too, but understanding what happens graphically can really help you wrap your mind around what's really happening with that domain and range, because you know what those parent functions look like. Okay. So let's add these. G plus f of x. So that's going to be g, which is the square root of x minus 2, plus f of x, which is the square root of x plus 6. Can I actually add those together? No, I cannot. Okay, I cannot add them together, so that's just it. That is g plus f of x. Now I got to look at the domain. The domain is the intersection of these two things, all right? So, negative 6 to infinity and 2 to infinity, right? So I can only use what both of them have in common. So what do you think my domain is going to be? think of this on a number line, right? So here's I am on the number line. This is -6. This is 2. Remember doing inequalities and stuff on the number line? So this one is this here. Yes? This one is this here. So I only get to use what both of them have. So do I get to use any of these numbers here? No. So am I using x is greater than or equal to -6 or x is greater than or equal to 2? 2. Does that make sense to you? That's where the overlap is. So if you need to actually draw yourself a little number line to wrap your mind around it, nothing wrong with that. This is going to be x is greater than or equal to 2. That's my answer. Now that's the domain for a, b, and c, so I don't have to overthink anything. F minus g, so f is the square root of x plus 6 minus g of x, which is the square root of x minus 2. Do I get to actually combine any of that? Nope, I sure don't. So that is equal to f minus g of x. And my domain is the same. X is greater than or equal to 2. Everybody okay with all that so far? All right, so g times f of x. G of x is the square root of x minus 2 times f of x, which is the square root of x plus 6. Can I combine those? Let me ask you this. What is the square root of 3 times the square root of 2? That's the square root of 6, right? If I add them, I don't get to do anything. If I multiply them, I do get to multiply what's underneath. That means that this is the square root of x minus 2 times x plus 6. Okay, multiplying them, you do get to put them together. So then I have to multiply this correctly with my FOIL, right? So this gives me the square root. X times x is x squared. 6 times x is 6x. Negative 2 and x is negative 2x. So that leaves me with a 4x minus 12. Okay. And that's equal to g times f of x. I sort of skipped a step in there. I did it in my head, but do you see what I did? I combined the x's at the same time. All right, and can I simplify that? That I can't simplify. So then that means that this domain here is still x is greater than or equal to 2. So now I'm to the quotient. G of x cannot equal 0 because it's in the denominator. That means the square root of x minus 2 cannot equal 0. If I square both sides, now x minus 2 cannot equal 0. So x cannot equal what? 2. That's a further restriction. So I come and substitute that in. My f of x is the square root of x plus 6 over g of x, which is the square root of x minus 2. Can I simplify that at all? No. But am I allowed to leave a square root in the denominator? No. So I have to rationalize, right? Which means I multiply by this. This is not nearly as bad as you think it's going to be, so it's all okay. Right? You multiply by whatever that square root is. Now, these two things, did I already multiply those together? Yeah, I did that right there, so I don't have to think about that again. That gives me the square root of x squared plus 4x minus 12 over, and then what's the square root of x minus 2 times the square root of x minus 2? X minus 2. That's why you did it, to make the square root go away, right? X minus 2. And that's equal to f over g of x. Okay, now, my domain has a little bit more of a restriction. I had that x was greater than or equal to 2. Now I'm saying x cannot equal 2. So that means that x has to do what? Greater than 2. Very good. There's my whole answer. Okay. Any questions at this point? We good? All right, you can do this. Now, let's look at what's happening here. Here, I'm just evaluating them. I don't care about the domain. I just have to evaluate it. I can find this algebraically first, but I don't have to. This is f plus g of 5. So I just have to evaluate 5 in both of them. So f of 5 is going to be 4 minus 5 squared plus g of 5 is going to be 2 times 5 plus 8. You see how I just put them both together? Well, okay with that? So that gives me 4 minus 25 plus 10 plus 8. So if I was doing this, I wouldn't just go straight left to right. I'd say the 10 and the 8, pretty easy to put together for like 18, right? And then add 4, so that's going to be 22. So I have a positive 22 and a negative 25. What does that give me? Negative 3. F plus g of 5 is equal to negative 3. So then, maybe I should have written out the other part. F times g of negative 2. So let's just do f times g is going to be, f is 4 minus x squared times g, which is 2x plus 8. Now, I don't have to actually FOIL that because I'm evaluating, right? So once I substitute in that negative 2, that gives me 4 minus negative 2 squared times 2 times negative 2 plus 8. Does everybody understand where everything's coming from? Please speak up if you don't. Okay. So this gives me 4 minus, what's a negative 2 squared? 4 times negative 4 plus 8. But once I get this, does it even matter what's happening here? What's 4 minus 4? 0. And what's 0 times anything? 0. So I didn't even, like if this was something crazy hard, it doesn't even matter. You got 0 times whatever that is. So that means that f times g of negative 2 is equal to 0. And 0 is an okay answer. Sometimes when y'all get 0, also you're like, I think I did something wrong. No, it's okay to get 0. Any questions at all? Now, when I give you the assignment, remember, front only. Front only, and you're going to turn that in to me on Wednesday. And when we finish it, I'll give you another one so that you can do the back, because the back's coming from a different lesson. Don't even look at the back yet, okay? Are we good? Any questions at all? All right.